Alright, so in today's video what we're going to be talking about are discriminants, particularly uh, what the discriminant does for us in a quadratic equation. Now, for those of you that don't remember what a discriminant is, it is right here. It's that negative or b squared minus 4ac, and where that comes from is the quadratic formula, which if you don't remember it is the opposite of b plus or minus the square root of b squared minus 4ac over 2a. The stuff underneath the square root symbol is generally referred to as a radicand. And so what we're really looking at is what does that radicand produce? And based on the number, it tells us a little bit of a story that the quadratic is going to take. It will tell us the number of solutions that it has and the type of solutions that it has. And what we see here are exactly that. If the discriminant is exactly equal to 0, we will have one root only. If the discriminant is greater than 0, we will have two real roots, meaning real in both of these, meaning that it touches the x-axis. So here when we're talking about real roots, it means it actually touches the x-axis. So if we were to graph something, a parabola, it has to actually touch the x-axis. And the last one, if the discriminant is less than 0, we will have two complex or two imaginary roots. And something like that typically is a parabola where it never touches the x-axis at all. So let's take a look and see how it is used. Oh, real quick, this is actually pretty useful information, so definitely make sure you get a copy down. If the discriminant is a perfect square, your solutions will be real numbers. They'll be rational numbers, meaning like a whole number or a fraction that's like a repeating or a terminating decimal. But the neat thing is that it can be solved by factoring. Now, if the discriminant is not a perfect square, we would have to rely on the quadratic formula in order to be able to solve it. But we'll take a look at that here in a little bit. So here, keep in mind the quadratic formula, or the standard form of quadratic, is ax squared plus bx plus c is equal to 0. So we're kind of using that model when it comes to figuring out, well, what do we substitute into the discriminant to see what type of solutions that we have. So in this example, the 3 is the a term, the negative 8 would be b, and c is the 4. So in math, I always recommend, anytime you're using a rule or an equation of any kind, I always recommend writing it down each and every time that you use it. It just facilitates good fundamental math, remembering things when you need it, if you're not provided a formula chart, things like that. So the discriminant is simply b squared minus 4 times a times c. So b squared is going to be substituted with a negative 8, so I'm going to say negative 8 squared minus 4 times the a value, which is 3, times the c value, which is 4. Now this is just an expression. We're not setting it equal to anything. We're just going to simplify it. So negative 8 squared is going to give me a positive 64. Remember, when you square a negative number, particularly on your calculator, make sure you put that negative number in parentheses before you square it. And here, negative 4 times 3 times positive 4 is going to give me 48. And if I take the difference of those two like terms, that simplifies to just be the number 16. So the discriminant simplified to be the number 16. So this tells us a couple things. First of all, the discriminant is greater than 0. That means there are two real solutions. not only are there two real solutions, but 16 is a perfect square. So because the discriminant, let's keep it that way, because the discriminant is a perfect square, the roots will be rational. Now, this is not something that is necessary, but I feel it's important enough to kind of demonstrate for you as proof, because I don't always like to say, well, just take my word for it because I'm the teacher and I know better. I like to, whenever I can, demonstrate why. What is the reason why? So if this is true, that because the discriminant is greater than 0, there's two real solutions, and because the discriminant is a perfect square, the roots are rational, meaning it should be factorable. Well, let's factor it real quick. So 3x squared minus 8x plus 4 equals 0. Let's factor this. Now, I'm not going to go into complete detail about how I'm going to factor it. Maybe you've seen it, maybe you haven't seen it, this particular method, but when we get more into detail on factoring, I will be happy to explain it in further detail. But basically what I do is I take the a term and I simplify it to 1, but in so doing, I also multiply it to the c term. So the 3 times 4 gives me 12. And then from there, it's much easier for us to visually see how we can factor it. If I open up my two sets of parentheses that I would need here, I'm going to say x here and x here. So the two factors of 12 that can combine to give me an 8 and still multiply together to give me a 12 would be a negative 6 and a negative 2 in this case. Now, the 3 is not completely gone. It's not like we made it go away. We're going to take it and put it here. So I'm going to say that is over 3 and that is over 3. And here, the 6 over 3 simplifies to be just 2. And this one, because it doesn't simplify, we would just kick this up here and say that's 3x minus 2. So those would be the two factors. And just double check me if you feel like it. Foil that back out, and you'll wind back up to 3x squared minus 8x plus 4. But those would be the two factors that, so first of all, the discriminant, because it's a perfect square, says it should be able to be factored, which we can. And there are two real solutions. So if I set both of those factors equal to 0, that'll tell me what the solutions are. So anyway, I just wanted to throw that out there as evidence rather than just saying take my word for it. Okay, next example, same type of situation, but in this case, the problem is not written in standard form, so I'm going to put it in standard form. Move the 7x over through addition, and that will be plus 7x, and move the 4 over through subtraction, and that will be minus 4 is equal to 0. Now, once we have that in standard form, again, all we're concerned about right now is what is the value of the discriminant, b squared minus 4ac. Well, in this case, b is 7, so I'm going to say 7 squared minus 4 times a, which is 5, times c, which is a negative 4. And simplify the expression. Well, 7 squared, 49. Negative 4 times 5 times negative 4 will give you a positive 80. And those two like terms combine to give you a 129. So that is the value of the discriminant. Now, this tells us a couple things. Again, like in the last example, the discriminant is greater than 0, so there are two real solutions. There's two real solutions. Now, unfortunately, 129 is not a perfect square, so that means it can't be factored. So since it can't be factored, that tells us the solutions the solutions are irrational. They're still real, but they're going to give me some weird number. Now, because the discriminant is not a perfect square, that tells you that we should not be able to factor it. So again, I just want to take this opportunity to prove it to you, rather than simply saying, take my word because I'm the teacher. So 5x squared plus 7x minus 4. I'm going to try and factor this in the exact same method that I did before. I'm going to change the a term to be 1. The b term stays the same, and I'm going to multiply a and c together, so that would be minus 20 equals 0. Now here, typically what we would do is we would say, okay, well, what are the factors of c that could add together in such a way to give me the b term, which is in this case is 7. So the factors of 20 are 1 and 20, and 2 and 10, and 4 and 5, and that is it. And you can see in no way, no matter how the signs are placed, there's no way that I can combine those numbers through addition that in any way are going to give me a 7. So that's what tells me, that is the evidence that proves that whenever the discriminant is not a perfect square, that we can't factor the discriminant. We would have to solve that when using the quadratic formula. Next example here, again, it's not in standard form, so the very first thing we want to do is put it in standard form. So 4x squared, and generally speaking, just in case you see it this way, if the function is, or if the equation is not in standard form, I always like to try and make the largest term, meaning the largest exponent term, a positive number. So if, for instance, the 4x was a negative, I would move it to the right side to make sure that the largest term was a positive value. So plus 12x, and then bring the 9 over through addition, that will be plus 9 equals 0. Now, again, the discriminant, b squared minus 4ac. B in this case is 12, so I'm going to say 12 squared minus 4 times 4, the a term, and c is 9. And let's simplify it, see what we get. Well, 12 squared is 144. Negative 4 times positive 4 times positive 9 is going to give you another 144. But these are opposites and they cancel out, and so the discriminant works out to be a 0. So this tells us a couple of things. First of all, the discriminant is equal to 0. So according to the stuff that we had at the beginning of the presentation, that means there's only one real solution. There's only one real solution. Okay? Now 0, I guess you could think of that as a perfect square. So that means we should be able to factor it. Now, again, this is not necessary. I'm not going to be asking you to do this on your assignment, but I want you to just not take my word for it. Let's prove why it is factorable and that it only has one factor in this case. So 4x squared plus 12x plus 9 equals 0. I'm going to use the same trick that I've been doing on the previous two examples. Make the a term 1 and multiply the a and c terms together while leaving b alone. So 4 times 9, that's going to give me a positive 36 here. And you can see pretty clearly that the factors of 36 that would add together to give you a 12 are going to be x plus 6 and x plus 6 again. Now here you can see already that these are the same factor. Even though there are two of them, they're the same. That means that even if I set both of them equal to 0, there would only be one real solution. Now if I put the 4 back in the way I'm supposed to, that would give me, those would simplify to be like a 3 over 2. So that would give me 2x plus 3 and 2x plus 3. Still the same factor. So because there's even though there are two of them, it's the exact same thing. That's what tells you that there's only one real solution. So last example here, guys, and then we're going to be done. And I think by process of elimination, you can tell, well, we've seen one that was a perfect square, one that gave us 0, one that was two real answers, but irrational. So that leaves us with an example where we're going to have a discriminant that is less than 0. So here, they were nice and left it to us in standard form. So let's go ahead and work out the discriminant. B squared minus 4ac. B in this case is negative 4, so I'm going to say negative 4 squared minus 4 times the 7, which is A, and the 2, which is the C term. And let's see what we get. Well, negative 4 squared is a positive 16. Negative 4 times 7 times 2 is going to be a negative 56. And combine those like terms, and that's going to give you a negative 40. So there is our discriminant. And again, this is going to tell us a couple things. The discriminant is less than 0. So there's two solutions still, but in this case, they are non-real. They are imaginary solutions. So there's two complex slash imaginary, however you want to think of it, imaginary solutions. All right? And because they're imaginary, well, we don't care really if they're repeated or whatever. We just know that they're complex. They're imaginary. Now, again, real quick, since I've been proving all of the other ones, let me go ahead and prove this one to you here, why there are two imaginary solutions. So this is going to require us to use the quadratic formula, which is b squared, oops, not b squared, getting ahead of myself, thinking of the discriminant. So here we're going to say the opposite of b plus or minus the discriminant, which is b squared minus 4ac over 2a. Well, we don't have to do all the work because we've already kind of figured out what the discriminant was. So the opposite of b would be a positive 4 plus or minus the square root of negative 40. We've already figured out the discriminant. Over 2 times a, well, that's just 14. So let's just put that there, 14. Simplify the radical, and the perfect square factors of 40 are just 4 and 10. So I can 4 plus minus simplify the square root of 40 there, and that's going to give me 2i with the remainder radical 10 over 14. And the 4 and the 2 have a common denominator of 14, so they would simplify to be 2 plus minus I radical 10 over 7. And again, just by seeing that I, that's telling you we have a positive version and a negative version of that, so that gives us our two imaginary answers. And that's pretty much it here. This is really just a review of the quadratic unit that you would have seen in Algebra 2. They don't really go too much into detail with imaginary numbers, I don't believe. Certainly not, probably not as much as we have in this course, but it at least gives you a good idea of what we're talking about. So thanks for watching. If you have any questions, make sure you bring them to my attention, and see you in class soon.